One. Okay, so here we are on question number 1, which is about coffee. I don't know if you're a coffee drinker, if you're having your coffee this morning. It says the amount of coffee that people drink per day is normally distributed with mean of 15 ounces. So that's the average amount. So the average person, I don't know if this is completely accurate. You could type into Google and probably find out what the average, how much coffee the average person drinks. But they're saying it's 15 ounces and a standard deviation of 5 ounces. So that makes sense? So the average person, the average or the mean, same thing, right? The mean or the average person has 15 ounces of coffee per day, but not everybody does the same thing. Some have more, some have less. How far off of that are they typically? 5 ounces. That's what standard deviation means, right? How much people are off the middle typically. So people are higher or lower than 15 ounces typically by 5 ounces. So they're up at 20 or they're down at 10. So most people, therefore, are between 10 and 20 ounces of coffee per day. That's what that means. Standard deviation, typical deviation, like how far they're off the middle. So the middle is 15. Most people are right around 15, but there's some variation above that and below that by about 5 typically. Now, some people go way higher and way lower, but typically people are around that by 5 ounces. So they go down to 10 and up to 20 typically. Now, 35 randomly selected people are surveyed. So they say, hey, let's check this out. Let's ask 35 people at random how much coffee they drink per day. Let's try to figure that out and see what we learn. Okay, so they come on down here and they're asking us, what is the distribution of X? And then the next question is going to be, what is the distribution of X bar? Okay, so there really is some theory behind this, but I don't want to bore you with too much theory. I want to practically tell you how to get the answers. So first off, what's the difference between X and X bar? Do you guys remember, what does it mean when there's a bar over something? What does X bar mean? Anybody remember that? X bar is the average or the mean. So when we put a bar over something, we're talking about the average or the mean. Okay, so here's the deal. This question is very similar, super similar to the questions we answered last time in chapter 6, isn't it? It looks almost exactly the same, and it is almost exactly the same. Really, today's lecture is probably going to be very easy for you because it's not much different. It's only a little bit. There's really only one little thing you're going to have to do different. Otherwise, it's exactly the same as chapter 6, which is kind of nice, isn't it? To not have too much new stuff to worry about. The only new thing here in chapter 7 is the fact that they're going to give us a group. So X bar is the average or mean of a group, whereas X is one individual, which is what we did in chapter 6. So chapter 6, the chapter we did last time, was all about one individual. In other words, what's the probability that if I grab one person at random, that they're going to be a person who drinks 20 ounces of coffee a day, or whatever question they want to ask us. Versus today, they're going to ask us about grabbing a group of people and the average of the group. Is that making sense? Look down here at the first two questions. I mean, the C and the D. You'll see what I mean. Look at question C. What is the probability that, see the number right here? 1 randomly selected person. Whereas, look at question D. Actually, let me change my color for emphasis. 1. In fact, I just keep changing my mind here. I really want it to be clear. 1. But I'm going to highlight it. 1 versus down here, 35 people average. See that difference? They're both asking between 14.9 and 15.4. Between 14.9 and 15.4, huh? So that part's the same. Do you see how very similar question C and D are? There's only one slight difference. Question C is about 1 randomly selected person, and question D is for 35 people, the average amount of coffee that the 35 people drink. See the difference? This is what chapter 7 is all about. This is what chapter 6 was all about. So chapter 6 was all about 1 person at a time. Chapter 7 today, what's new today is that we have 35 people and we're talking about their average, their X bar, their average or mean for a group, not one individual. Okay, well, how does that change the game? Not much at all. First off, what do they want me to do up here? They want us to give the mean and then the standard deviation. They're just saying, what's the distribution? What's the mean? Well, it says up here the mean is 15. Same thing here, 15. What's the standard deviation? It says right here, 5. But here comes the new part. You ready? I've got to go 5 divided by the square root of 35. What is that? That's because you're talking about a group, and the standard deviation changes when you've got a group. How does it change? It becomes the old standard deviation, 5 divided by the square root of n. So let me write it up here. For a group size of n, let's say n, the new standard deviation is old standard, well, let's just say it's the standard deviation, you know? It's the standard deviation divided by the square root of n. That's it. That's all that's new today. Really, that is it. This is going to be a nice, easy day for us, I think. This is all new.
Quick question.
That's what I'm doing right here. That's what I'm doing right here. 5 divided by the square root of 35, because n is the group size. And see, there's n right there. N is 35. That's the group size. So if you take your calculator, you take 5 divided by the square root of 35. I'm doing it too. You got to find the square root button on your calculator. Let me write the answer here. This is going to equal, what is it? 0.8451. I round to, 5.2, huh? I got to round 5.2 because it said round to 4 places. It was 84515. So it rounds to 8452 for me anyway, for my example. Is that making sense? Are you guys able to find the square root button? So 5 divided by the square root button is over by the x squared. You've got to hit second and the x squared button, because right above the x squared button is the square root. And so you got to get the second function of the x squared button and then hit enter. Oh, wait, no, not enter. Sorry, I'm getting off here. Then you got to hit 35 and then enter. So there's what you got to type into your calculator. And then you got to round it, 84515, and it'll round to 8452. Is everybody seeing what I'm saying there? So you've got to hit second. Remember, the second is a blue button because it gives you the blue stuff above the keys. So above the x squared button is a square root. So we've got to hit 5 divided by second square root 35, enter. And we get 0.8452. Good so far? Questions so far? Okay, I'm going to move on now. Coming on down, so see the difference when they put the X bar, that's the average. That means average of a group. And for a group, like it says up here, for a group of size n, the only thing that the mean doesn't change. The mean's just the middle, just the average. That doesn't change. The only thing that changes is the standard deviation. The new standard deviation is the old standard deviation divided by the square root of n, where n is the size of your group. All right, let's do it. Let's do part C. Now, how do you do part C? We did these last time in chapter 6. What is the probability that one randomly selected person drinks between 14.9 and 15.4 ounces of coffee per day? You just grab somebody at random. What's the chance they're going to be somebody who drinks between 14.9 and 15.4 ounces of coffee per day? Well, we did this back in chapter 6. Do you remember what we do on our calculator?
Wasn't it second distribution?
Yeah, right. You got to go second distribution and then find normal CDF. Exactly. Normal CDF. And then when you go to normal CDF, it'll ask you for 4 things. In fact, maybe what I should do is move it off to the side where there's a little more room. Let me do that for us. So I'll grab this one, part C, and I'll go like over here. So part C, for one, which is for one person. Yeah, exactly right. You've got to go to the normal CDF, which is exactly, it's under second and VARs or distribution, which is above that. That's right. Hit second VARs, and then you choose normal CDF, just like we did last time. And then it'll ask you for, what does it ask? A lower, upper, right? It'll say lower or left, and then upper or right. And the lower is going to be the 14.9. The upper is going to be the 15.4, right? Between 14.9 and 15.4. The lower, the upper, and then it'll ask you for the mean and the standard deviation. And the mean is going to be, what is it, 15, in my example. And the standard deviation, 5. And hit the buttons. I'm going to do it too. And let's see what we get. So it's going to be just like last time. Nothing new here. So this is going to be 0.03985. So round to 9. You got to round to 4 places. 0.0399 is what I got. Is that making sense so far? So that's not new. That's old stuff. Now the next part, part D, will have the new wrinkle, which is not very much new, but a little bit new. 0.0399. So that's the probability, 3.99% chance that if you grab somebody at random, that they will be a person who drinks between 14.9 and 15.4 ounces of coffee per day. 0.0399 or 3.99% chance of that happening. Now, for questions, I'm assuming you're good there, but feel free to speak up if you have questions. Now, for part D, they asked almost the same question. I mean, super, super similar. Only difference, part D right here. Whoop, that was not a D. I'm on my wrong tool here. Here we go. D. So for part D right here, the only difference, it's going to be, it's a group for 35 people. group of size n equals 35, right? So it's not for one person like part C was. It's for a group size 35, and they're asking about the average. So it's the average for a group. So they're saying we didn't just ask one person how much coffee they drink. We asked a group of people. We asked 35 people. We said, hey, you 35 people, how much coffee do you drink on average? How much coffee do you drink? We took all their answers and we averaged them together. Does that make sense? We didn't just ask one person, we asked 35 people, and then we computed the average for that group of 35 people. So if you take the average of a group of 35 people, here's the question. What's the probability, find the probability, that the average for that group is going to be, same question, between 14.9 and 15.4. So how do we do it? Well, basically, generally the same way. We have to hit second, vars. It's going to be almost the same thing with one small wrinkle, which is the distribution. Go to normal CDF. Exact same thing as last time. Then they're going to have lower and upper, lower or left, and then upper or right. That's going to be same thing, 14.9, 15.4, good so far. Mean, that's the same, 15. Notice these are all the same, right? No difference so far. Now here comes the difference. SD, standard deviation, right? That's the part we handle differently. So what am I going to do for the standard deviation? I'm going to take the old standard deviation 5 and divide by the square root of 35. And you don't even need to figure it out ahead of time. Let me move it down here where you can see it better. So SD is going to be 5 divided by the square root of 35. So that's different. The other one was just 5. The new one will be 5 divided by the square root of 35. That's it. That's the only difference for, this is basically all of chapter 7. It's exactly like chapter 6, except when they give you a group, size whatever, 35, you change the standard deviation to be divided by the square root of that group number. That's it. Everything else is the same. So let's do it. I'm going to go back to my calculator, do normal CDF, put in those numbers. What is it?
So when you log it in, do you put just 5 divided by 35, or do you put the 0.84?
Yeah, put in just 5 divided by square root of 35. Great question. Let me actually show it. That's a great question. Let me show it. So I'm going to go back. You guys are seeing my laptop now, right? And I'm going to go to my little computer calculator thing. Get it up here. There it is. All right. So yeah, let me actually do it with y'all. Hit second. Oh, wait, here. Bars. Wait, I forgot to. Okay, so here. There we go. So there's what I pressed so far. Second in vars. Y'all can see that, right? And then I go down to, normal CDF, hit enter. Okay, so it says lower, upper. So what was my lower? 14.9. 14 point. Oh, whoops, sorry, I moved it. There we go. Oh, no, it's being problematic. Here we go. 14.9. 14.9, go down, and what was that? So 15.4. 15. I don't know how to, let me move this up there. There we go. 15.4 down. Now, mean is that Greek mu thing that looks like a U. 15. Go on down. Now, here we go. Everybody watching? Everybody seeing this? That was a great question that was asked. Here's what you do. You literally just type in 5 divided by, I'm going to go second, x squared, which is square root. See the square root there? 35. So you don't have to figure, that was a great question. You don't have to figure out the decimal value ahead of time. Don't bother with that. That would slow you down, and it wouldn't even be quite as accurate because you couldn't type in probably all those decimal points. It's a big pain. No, just type this in straight, just like I am. See how I'm just putting, I'm not even going to close those parentheses. You don't even need to close parentheses. Just open them and it's good. 5 divided by square root of 35. Everybody seeing that? Just literally type that in. That's the only thing that's different. And then I'm going to hit enter.
Hey, Mr. Heron.
Yeah.
We solved it in section B, so.
No. This is the new part. See the new part? The new part has the square root. So in section B, great question. In section B, we only put 5 here. Here would be the answer from section B. We only put the 5. But what's new for section C, it's actually D, I'm sorry, it's D, is, oh, I know what you mean. Oh, yeah, I'm sorry, Juan, I'm not paying attention to your question. You said it well, and I'm getting confused. You're saying, why don't we just grab the point 8452 back from section B? You could. You totally could. That's okay. I would encourage you to just do it this way. This way will be more accurate, and in general, it'll be quicker. And when you get to the test, you will not have just done part B. It won't work that way. So this will be a way better habit for you to be in. That makes sense?
Okay.
The test, you'll
Yes,
be just directly asked this question. Yeah, that's a good point, Juan. I see what you're saying, because we did just do the part B with the 8452. You're right. But on the test, we will not have just done that. They'll just ask us this question alone. And so it's a good habit to just go ahead and put that in. Good point, though. I appreciate you mentioning that. Is that good? Yeah, so just go ahead and put that right. Either one will work. Either one will work. And hit enter, enter, enter. There it is, 0.22, I guess we'd round that 91, 2291. 2291. So if you're good there, I'll go back to my iPad screen here. Somehow, if I can. Oh, here it is. I moved it up here and I lost it. All right, back to my iPad. All right, so, okay, so let's finish. So what was that? 2291, right? So that was 0.2291 after the rounding. Does that make sense? So the only new thing today is we're just dividing by the square root of the group number. That's it. That's all, which is nice. Okay, let's come down now on part F. But feel free to speak up if you have questions. Put something in the chat box as well. I'm good either way. I'm going to move on now with question F. And they're asking Q1, Q3, IQR, which is a great question. Let's see if we can do those. So if you're okay, I'm going to erase the work that's here. You've all.
We missed question E.
Oh, you're right. I got to do E. You're right. I'll do E as well. Thank you. Everybody got this copied down? You need to do a screenshot. Do it now. I'm about to erase all my work. So if you want to screenshot it or use your phone or your computer, whatever, take a screenshot now. Of course, it'll be on a video in a couple hours. It'll be out there for you to watch it again. All right, so I'm about to erase it. I hope you got what you needed. Here we go. All right, I'm going to make room for, yeah, I got to do E and F. You're right. Thank you, Brenda. E and F. So let's do E and F. Okay, so part E says, for part D, is the assumption that the distribution is normal necessary. What are they talking about? Well, basically, here's the deal. The answer is yes when the group size is less than 30. The answer is no when the group size is 30 or more. Now that has to do with a little bit of, what's our group size on this problem?
35?
35. So is our answer a yes or a no?
No.
Correct. Ours is a no. It's a no. Because our group size is 30 or more. Our group size is 35. So now, the reason why that's the case has to do with a little bit of statistical theory. And I'm afraid you might start taking a nap if I do too much, if I talk about too much statistical theory. It's not, but let me mention a little bit since it's coming up here. I'll keep it brief, I promise. Basically, here's the deal. When you have big group, what's been proven statistically is that when you have a big group of size 30 or more, so if you have 30 or more, it forces, let's not say forces, it guarantees 30 or more automatically 30 or more. Yeah, let me not say yeah, well, it's right, automatically, yeah. I'm changing my mind. Automatically guarantees that the curve is normal. So that's basically the statistical theory. And if you'd like to talk more about it, I would love to explain to you more of the theory behind that. But it's not really something you totally need to know practically to do the stats. You know, I'm mainly focused on your ability when this class is over to read and understand professional data, because that's what it's about, right? Probably you're not going to become a statistical theorist, probably most of you, but you will read studies in which they cite standard deviations and means and evidence for different things based on statistical studies. I want you to be a well-informed consumer. That's what I think this is a GE class aimed at making you a wise professional who can understand that language. So just know that in general, when you have a group of 30 or more, it guarantees that things are normal. Therefore, we don't need to assume normal. It gives it to you automatically. So, yeah, let me write that in. No need for normal assumption. Right? You don't need to assume that and what do I mean by normal? I mean bell curve. Remember we talked about this is what normal means. Normally distributed means bell curve. It's the way things are usually or normally distributed. They normally spread out in a bell curve. Remember how we talked about that last time? Which means it's kind of humped in the middle, right? It goes high in the middle, then goes low, which means most are average. Most, whatever it is you're measuring, in this case, coffee, how much coffee people drink, whatever coffee, most people are right around the middle, which was 15, right? Yeah, most people are right around the middle. Some people drink like 30 ounces a day, but not many. Most are right around the 15. Some people drink none, but not many, right? Most are right around 15. Most are right around the middle. So most things in life have a bell curve, which means they're humped in the middle. They go high in the middle. They're tallest in the middle. So and then they did tell us that, right? They said up here normally distributed. You see the words, the original word said the amount of coffee people drink per day is normally distributed. Normally distributed. So they did tell us it's normally distributed, but we actually didn't even need to know that, because when you're talking about 30 or more, it's automatically going to be normally distributed, even if it was not originally. When you start taking averages of groups of 30 or more, that data will be normally distributed automatically. All right, enough theory. All you, so just put this in your notes for the exam that we take next week. If the group size is less than 30, then yes, you need them to tell you it's normally distributed. But if the group size is 30 or more, no, you don't need them to tell you that. You got it automatically. All right, enough theory. On to part F. Let's answer part F. Part F is asking for the IQR and the average for 35 coffee drinkers. Okay. Now, we did some of this last time, Q1, Q3. It's going to be the same way. We're going to use the inverse norm, exactly like we did back in chapter 6. The only difference, again, is it's going to be right up here. The new standard deviation is going to be the old one divided by the square root of n, because we're talking about the average of a group of 35. That's going to be the only difference. Otherwise, it's going to be exactly what we did with inverse norm back in chapter 6. Now, I'm saying all this, I'm about to erase all that statistical theory stuff, so I have room to do Q1 and Q3. So if you need to take a screenshot, do it now. I'll give you like 5 seconds here. Take your screenshots if you need them. All right, I'm going to erase. So we have room to answer the last question. There's a no there. Whoops, I scribbled it up. No. All right, so let's answer the last question. So for Q1, so how do you do Q1? What is this Q1, Q3 stuff mean? I hope you're getting more and more comfortable with that. Remember, Q1 is like quarter. So it's like if you broke your data set into 4 quarters, right? If this is 25%, 25%, 25%, and 25%, this is Q1 right here. This is Q3 right there. It's like a football game or a basketball game. Q1 is the end of the first quarter, and Q3 is the end of the third quarter. Remember what they are? Q1's the end of the first quarter, Q3 is the end of the third quarter for the bell curve, the normal curve, just like football game, basketball game, right? So therefore, when they ask us in this question, they say, all right, we want to know Q1. They're basically saying you're right here at the end of the first quarter of the data. So how are we going to do it? Well, let's go to our notes. I have down here for you. Here's the exam. Now, I just updated the exam 2 notes. I added this new piece of the puzzle. I realized that'd be helpful for you. I just did it like minutes ago. So it's new on the website. So if you want to go out there to our course website and download a new copy of exam 2 notes. This is the exam 2 notes. You'll have that new, I put the new one out there. That's what I was doing the first 5 minutes of class there. Is I put the new version that has this new piece for you out there in the exam 2 notes. I updated the exam 2 notes. So go out there and grab this piece for yourself, and you'll download it again afresh. Get the new version, get the new latest greatest updated version 10.0 or whatever it is, iPhone 10L. We're in exam 2 notes 10.0. All right, so now how do we do it? So let's go back. What are they doing on this? Well, they're saying Q1. Q1 means 25% below me, doesn't it? So they're doing what? They're giving me a percentage, aren't they? They're not asking me for a percentage. No, they're giving me a percentage, aren't they? When they tell me Q1, they're giving me a percentage, right? So these two, when they tell me Q1 or Q3, we know that means a quarter of the game is over, 25%. If they give me Q3, that's 75% of the game is over, right? So they're giving us a percentage. So we're going to use inverse norm. Now, how do we know which of these two inverse norms we're going to use? Well, for n equals 1, you just use this one. But if n is more than 1 for a group, then you do the same exact thing, but see what you do at the end? You divide by the square root of n, the standard deviation divided by the square root of n. See how it's exactly the same thing? It's exactly the same thing up here for the normal CDF. See, it's divided by the square root of n for a group. It's the same thing. That's the only new part of today. So let's go do it. It's going to be this one, isn't it? We have a group size 35. So I'm going to need to take the standard deviation divided by the square root of 35, aren't I? Let's do it. So Q1, we're going to go to our calculator, find inverse norm on your calculator, and that'll ask you area to the left, and that's the point. Got to put the decimal version, right? 0.25. It'll ask you the mean, and the mean is the average amount of coffee per day, 15. That's still, up there at the top, the mean was 15. Standard deviation, you know it, right? 15 divided by square root 35. So that's what's different. When you have a group, you've got to change the standard deviation. That's it. Hit the buttons.
Wait, it's 15?
Oh,
I thought
I'm
it was 5.
sorry. It's 5. You're right. I was testing you. Well done. I was just being goofy. Thank you for helping me. 5 divided by the square root of 35. Thank you. Standard deviation. The old standard was just 5, wasn't it? Not 15. Yeah, that's what you want to put in. Exactly. Hit the buttons. I'll show it now on my laptop graphing simulator thing. I mean, a TI-84 simulator. Let me do it. There it is. So I'm going to clear this, turn the calculator on, go down to inverse norm. Area, it is 0.25, so 0.25. That's the area to the left. The mean was 15, for mine anyway. And here it is. Here's the new part. Standard deviation 5 divided by second square root 35. Just like that. See how I'm just typing it in straight? You don't even need to use the decimal. Let the calculator do the work. It can figure out the decimal and figure out everything for you. Let the calculator do the heavy lifting. So I'm about to hit enter a bunch of times. Everybody good to there? This is for Q1. Hit enter, enter, enter. There it is, 14.4299. Oh, actually, that's going to round to 4300, isn't it? Because we got to round to 4 places. That 5 out here is going to round up this 299 to be 300. Everybody see that? All right, so let me go back to my iPad screen. All right, here we are back to the iPad screen, and oh, I forgot to write it down, honestly. Let me see, it's somewhere here. I can get it. Okay, there we go. It is 14.42995, huh? All right. Okay, so yeah, so the answer was, so for Q1, it came out to be 14.42995. 0.42995. Supposed to round to 4 places. So that 5 rounds up to 299 to be 300. 14.4300. 14.4300. Is that making sense there?
I put my answers in and it says that all 3 are wrong. Are we just rounding to the nearest ounce? Because it doesn't say that. I don't see that, but it says that all 3 of my answers are wrong.
Yeah, huh. Well, go ahead and click on the correct answer. I can help you after that. I don't think so. I think we're supposed to round to this many places. And then maybe it's totally different on that one. Okay, so let's try Q3. So for Q3, it's going to be the exact same thing. It's just you put in 0.75, right? So if I change this to Q3, this is just going to be 0.75 because for Q3, there's 75% of the graph is to the left. So I'll go back to my screen and now I'm going to do second distribution, inverse norm, and I'm just going to change this to 0.75 now. Everything else is the same. You don't need to change anything else. Everybody see that? Just 0.75 for Q3. Hit enter, enter. There it is. I got 15.5700. Let's go back. To my iPad. Okay, so that was 15.5700. And now, how do we do the IQR? Do you remember?
You subtract Q3 from Q1, or Q1 from Q3.
Exactly, yeah. Take the bigger one minus the smaller one. It's just the Q3 answer minus the Q1. Just subtract those two, that's right. So I'll do that on my calculator right now. And I'm getting 1.14. All right, yeah, so somebody mentioned that they were having trouble. Is this working out for you guys? Are you getting the right answers for Q1, Q3, and the IQR for your version?
Yeah, I did.
So did I. I'm fine.
Okay, so it sounds like it's working. So if anybody out there is not getting the right answer, you're probably putting the wrong thing into your calculator. It doesn't look like the question has any problems as far as rounding or anything weird like that, sounds like. So if you're getting the wrong answer, you're probably doing something wrong. And Crystal and I can help you afterwards in the breakout session. Any other general questions I can answer? Is there any confusion on how to do this one? So really, all of this, if I could just summarize, it's exactly the same as chapter 6. We're just going to, for all these questions, we're just going to do normal CDF and inverse norm. The only difference is if they give you a group, you have to divide the standard deviation by the square root of the group size. All right, let's stop that.